Okay, then we'll start uh,
Okay, okay, sir. Okay.
rest part of this JS schedule. So today we will cover the topology and all the elevation related data information and some basic practicals are there. So I will show you different basic features of the GIS. So now we will start. Then first of all, during digitization, we need some rules. So there are some rules are there. Based on these rules, the digitization works for point, line, polygon. तो जो भी है कुछ नियम है टोपोलॉजी का जिसमें कि हम जब ड्रॉ करते हैं उसमें कुछ एरर आता है तो उसको हमको अवॉइड करना है सो ये जो जितना भी है अभी एक से एक डिस्कस करेंगे सो टोपोलॉजी इन द जीआईएस टर्म इज जनरली द special relation between the geometric feature in GIS such as connectivity, adjacency and containment. So जो भी है connectivity between two polygon, connectivity between two polygons. So there is a relationships between two polygon during our digitizations. Then adjacency, जो network boundaries are there. Then containment, so polygon inside the polygon. How these are arranged in a different way. So that's why some rules are there. So which these rules are discussed. So why topology important? Because it maintain data quality and consistency and enable network analysis, road utility network. So it prevents spatial errors like overlapping error. एक polygon को ऊपर और एक polygon अगर आ जाएगा तो we have it shows double attribute, double information, and area also shows the double area. So these are creating the error in the map or in data. So this should be avoided during our work, and then essential in editing, validating, and analyzing. So topology this can maintain this uh, quality of the work. Then some topology rules are there that for the polygon it is topological rule example is one. There are five example. So one of them first is it must not overlap.
Overlap.
So it cannot be overlap with other polygon. If one is overlap with other polygon, then it creates the error. So ensure no two polygons share the same area. So this is the example and it shows the features. So it may be the polygon to polygon overlapping, or it may be for line to line overlapping. So if it is happen, then all the data are creating the problem for accuracy of this information. So it should be avoided, and for this there are different tools are there. I will show you after this discussion. Then it must not have gaps. So if there is a gap between two polygon or inside the polygon, then it is a missing information about an features or about any object. So there should not be any hole. It is in the red area. It is look like one hole. So it is the gap. So it should be avoided, and for this type of mistake. Then for most of the line drawing digitization, some continuous network is needed for drawing the road drainage. So if there is not connectivity, then it shows also error. So these are some error in the red line dot. So it should be avoided. And then point must be covered by polygon. Suppose there are different number of polygons are there, so different number of informations are there. So if we extract the information with the help of some points, so it should be inside the points should be inside the polygon, so that we can extract the information. So in this area, this is the polygon and this is the point. So it should be avoided, and it should be corrected with using this type of uh, changes or editing. Then line and polygon boundary must be covered by line. Suppose there are two type of features are there. One is line or one is polygon of a same area. Then it should be enclosed by the line in the polygon area. So this is the one of the example is there. So I will show you one of the example using ArcGIS. So this is one of our satellite image. It is a false color satellite image, and some of the polygons of the block boundary are there. And is a village boundary. Suppose we have to create one polygon. This is our polygon. So during creating one from polygon nearby this area, so we have to check it is which tool we are use. So कौन सा tool अब हम use कर रहे हैं. If we create same create polygon, then it create error. So one polygon is overlap with other. So the area is this common area is increased in the information. So during our edit, we should avoid the create polygon after creation of one polygon. So we have to create polygon using autocomplete polygon. So in this autocomplete, it can create a boundary. This is our outer boundary, and this outer boundary of one polygon is created the outer boundary of second polygon. Just click it. So this is the adjacency principle of the JS file. So this is there is no any error are found. So this type of techniques are used. Suppose we have created a area and we just deleted one polygon inside the polygon. So it create a hole. So we cannot select inside the polygon because it is not part of this polygon. So only this part is present. So this type of errors are also found sometimes due to some mistakes in the editing part or by mistake of some editing part. This type also created some issue. Then there are some line features are there. If it is not connected, then this is also one of the issue. So topological error can be uh, avoided during our digitizations of different point line polygon in different projects or different research work. Then we'll see digital elevation model. So different elevation models are there. Digital elevation model it is also called it DEM. So basically in the DEM, digital elevation model, a lot of satellites are creating this digital elevation model. And for example, so basically in this digital elevation model, it is a black and white, and that is called as panchromatic satellite image. So black shows the lower elevation informations, and white shows the top level and highest elevation informations. So from black to white, so gray variations are signifies the different elevation information. So we can create in different color also. So DEM is a digital representation of ground surface topology and terrain, and it represents bare earth elevation. So there is no artificial information, artificial features, height information are not included in this digital elevation model. And its application is in hydrological modeling like drainage pattern, flow accumulation, flow direction. All these applications are including the hydrological modelings are used. Then contour and slope analysis, elevation analysis. We will discuss the contour later. Then slope analysis, flood risk assessment based on the height information. Then orthorectification of satellite image. And some of the example of this DEM data is SRTM, that is Shuttle Radar Topographic Mission. It is one of the open source digital elevation model data which has a spatial resolution of 30 meters. It means each pixel is 30 into 30 meter. Then Nestor dam also there, leader derived dams are also there. So a lot of nowadays dam data are available. Some of them are freely available, and some are using in the different commercial purpose. So this is one of the image where the satellite data is there in the background. So if we see in the DEM satellite image, this hilly terrain area looks like this type of image, that is white and black. So this blacks area is the low area, that is the valley area, and this white area is the top elevation area. This is the DEM data. So looks like this is the map of the one of the DEM data. Then DEM pixel. So this is one of the graphics, 3D graphics, and this is the DEM data. So in this DEM data, every pixel, so as these are the satellite data. So each unit of this satellite data is a pixel. So each pixel contains some information of elevation. So this is the elevation information. The top level information is look like white, and low level is black. So this type of informations are there in the satellite image. So based on the height, it gives the different information, elevation information. So this is the example. Then we just zoom it and just look the pixel information. So these are the pixel of different height informations are there. So this is the totally bright area that shows the 117 meter, and this is the black area which shows the 80-meter elevation. So based on this, the color are changes in the gray value to total white value. This is about the dam. Then digital surface model is another digital elevation model. So in the DSM data, that is digital surface model, the elevation of all feature on the earth surface such as buildings, vegetations and trees. तो इसमें क्या होता है कि ओनली डेम डाटा में ओनली एलिवेशन हमको पता होता है, लेकिन डीएसएम में एलिवेशन विद फीचर्स, वी कैन नॉट आइडेंटिफाई एनी फीचर्स इन डेम डाटा. सो हमको पता नहीं चलता कि कौन सा फीचर क्या है, बिकॉज इट इज लुक लाइक ओनली वाइट एंड ब्लैक बेस्ड ऑन द एलिवेशन. बट सरफेस मॉडल में फीचर्स क्या है, किस टाइप का है, ये एक एग्जांपल है. तो ये एक सेटलमेंट एरिया है, एक रिवर है और एक ब्रिज है. इस टाइप का फीचर, सरफेस का फीचर along with height informations are given. So this is the surface, digital surface model, and before this there is a digital elevation model. So based on this, different applications like 3D city modeling, line of sight, solar radiations, telecommunications are there. And so some example of this data are photogrammetric data. A lot of photogrammetric techniques are there, softwares are there, including some radars data also working on the photogrammetric data. So LiDAR data, light detecting and ranging. Then UAV imagery also creates some digital surface model. Then digital terrain model. So it is also giving some information about the elevation information. So based on the vector data and along with this information of elevation, we can create digital terrain model. So this type of terrain models are created based on the different colors are given with the help of different height information. And what is the difference between distant terrain model and them? So in the this is the features of the terrain of the earth surface, which include some trees and some buildings or different artificial features are there. So DEM data, sometimes DEM data includes some trees and some artificial structure. So it creates some elevation information. But in the DTM data, only the surface elevations are given. So these are the difference. And for DSM and DTM, this is the DSM data, distance surface model. Then this is the DTM data, this is the terrain model. Only terrain informations are there. Terrain elevation is there, not the artificial features or any buildings or any uh, other features are included. Then what is the difference between the DEM, DSM and DTM? So in DEM, the trees or buildings are depends on source. It may be included in DM or sometimes it is excluded in the digital elevation model. But in digital surface model, it is also sometimes included and sometimes elevated. Terrain model, there is no any buildings informations are there, but it represents earth elevations. It represents surface elevation with object, and DTM is only bare earth. There is no artificial structure or artificial heights information are given in DTM. I generally use DM in general elevation mapping. DSM is specially used for urban and vegetation modeling, and
Sir,
DTM
X
also.
elevation, surface elevation, what's the difference, sir? Excuse me, sir.
What?
Representation means X elevation and surface elevation. What's the difference, sir, here?
Which data?
Represents, sir. X elevation, surface elevation with
Ah,
objects, bare depth elevation.
Earth elevation DM
DSM,
data generally.
DSM and
Okay,
DTM are understood, sir, but DM, what's the difference? X elevation
actually
and surface.
in the DM, actually in
Sir,
the DM data, sometimes we use some artificial structure, and sometimes we just eliminate the artificial structure like dam construction. Sometimes is dam is constructed in the lower elevation area, then It is artificial structure. So generally, we restrict the lower elevation area with creating the dam. So sometimes the sinkhole techniques are there. So in this sinkhole, we just average this landscape and just avoid the artificial structure in dam data. And sometimes also we included this artificial structure. So but generally we have to avoid some artificial structure for natural flowing direction of the drainage system or for different words. But generally dam data are not as so much high resolution data. Nowadays DTM and DSM are used for urban planning and very high elevations informations are there.
Yes. Okay.
Okay,
Thank you. Thank you, sir. Thank you.
thank you. Then source different SRTM, LIDAR, photogrammetry, and DSMs are there. Then it is also one of the elevation information like contour lines. What is contour lines? Contour lines are iso lines. This says that connect points of equal elevation of the map. So these are the line. Each line signifies the same height information of a particular one line. Then and different and the lower and upper lines are signifies the different elevations, but one characteristics of this contour line is that no any line will crosses over one line, so there is no uh, crossover of the different line in the contour map. In the contour map mostly used in the topo sheets with the same elevation. We just create, we just calculate the elevation of same uh, elevation of different points. Then we connect all this dotted and that create one polygon or line. So it's create a contour line. So purpose क्या है इसका? The visually represent the terrain shape and elevation, hills, valleys, slope, and depressions. Some depression area and some elevations area are shows in the 2D form, because height is in the 3D form. We cannot show one in the 2D map. That's why we just draw a control line of same elevation information. Then we give the information of the elevation, with what is the elevation of that point. Then we just signify these lines. So these lines are look like this, and these are, sometimes it is look the gray lines are there. Then how to identify different elevation areas? So it is one of the characteristics is closed lines and white lines are there. So closed lines means if these two lines are very close to each other, then it signifies the steep slope, हाई स्लोप एरिया है. तो अगर वो थोड़ा सा गैप है दो लाइन के अंदर, then it is a gentle slope. Slope is gradually increases. So what is used in GIS? It is derived. It can be derived and derived from DEM data or DSM data, and uses in topographic mapping, watershed analysis, slope modeling, and terrain visualization. This is the 2D contour map. So different sections are there. So which section are which type of information given? It is showing this type of map. So this is the contour polygon. This is the lines. So the 86 is the elevation in meter. Then 80, 70, 60, 50. So its dot means the top height, the round hill or contour in the circle oval shape. Then some saddle and some elevation areas are there, and this is the line which shows that it is a river or a drainage pattern. Then in these areas, this is the escarpment. Escarpment means sudden increase of height. Sometimes in the coastal area also we have just found. So if there is a closeness and suddenly create some closeness, then it is a escarpment or steep slopes are there. This shows there is a gorge, there is a gorge or waterfall area, and this shows there is a valley. This area is a valley. It is a river. Then both side it is a valley. So these are the some information based on these control lines are created. So some escarpment means this is the picture of the escarpment. So sudden increase of height within very small width of the area. This is one of the picture. So it is sudden increase of height. This is called escarpment. So it is a digital view. Most of the time, some of the waterfalls are also there in these escarpment areas. So this escarpment are look like this close lines in the control contour information. Then valley area. So in the contour area, these are the valleys. These are the valley area because there is a one one different wave-like patterns are there. So it is directed towards center of this line, and it shows there is a valley. What is the valley? Valley is generally a elongated low area often running between the hills. दो हिल के अंदर जो लो एलिवेशन एरिया है उसको वैली कहते हैं. And most of the time rivers are flowing in some of the valley. So this picture is the river flowing, so in both side of the valley. So it is also one of the picture of valley. Then saddle, these are the saddle, the two peak of this area, two peak and one depression area. So it is this area shows the saddle. Then ridge means top, elevated and sharp lines are there when we see in the satellite image. So these are the ridge. So these are showing they are not given in this area. So very ridge are very small area and a linear surface. So and this is called the pass, some Nathula Pass or other Jojila Pass. These are the like this. These are in the valley area and low-lying areas are there. So how these contour maps are created? So suppose this is the hilly terrain area. This is the hilly terrain area. We just calculated the difference height information, the top height and low height. Then we just calculate this same features in a one circle or one line, and it created one information that is 4,000 meter. Then after that, this area, second area, that is 3,500 meter area. So this area also plotted in the 2D map in a circle in equal interval, that is a 3,000. Likewise, all these informations are given from center to low level. So likewise, when the 3D map, the top is here, and in the 2D map, the center point or circle point, small circles are there. So it is at top elevation areas. So it's gradually increase, and in the last part there is the low elevation areas. So this peak hilly terrain area is shown in terms of contour line. In this type of features are created. This is the one of the contour of a total hilly terrain. So these type of contours are generally found in our Survey of India topo sheets. So this is the contour line. So in the middle areas, these are the top height areas, then it gradually decreases its heights, and in the this is the low height areas. Then the settlement started. So these areas are hilly terrain areas, and these are the control lines, and some informations are there also given: 500, 200 meter, 300 meter. This is 1300 meter. So in the survey of India toposits, and the control lines are also there. Then different spatial analysis are also there. So lot of attributes are there in the different features. Suppose we want to join one attribute with this some set file area. How to join one attribute having the unique ID. So it is a unique ID. Based on this unique ID, we just create another attribute. So in the practical, we just show you. So these are the line. Sorry, these are the point. So all these points are of some agricultural land of one of the district of Odisha. So some agricultural land informations are there. So in my shape file, point shape file, some of the informations are there, like serial number, project landscape, block, GP, village name. So in this shape file and in this attribute, we have some informations. So if we need some other information, and we want to add this information to this shape file and this attribute table of each data, then we have to join this data based on a and common and unique identified uh, number or ID. So uh, just see that the serial number is the unique ID. So we just to find which ID, which column is the unique ID. So we have some data in the foreign key. This is the foreign key. We have some serial number. There's the unique ID, but it has some name and some XY coordinates. So based on this serial number, there's the unique ID. So the serial number is present in this area, this data, and in this foreign key data. So some of the data are present in the foreign key, and some of the data are present in the agricultural land details shape file data. So we have to add some information based on this ID or based on this column. So how to add? Just go to join and relate, then join. So and it shows choose the field in this layer that join will be best. So we have some common column or column ID is there, though it is the serial number. So choose the table to join. So we have to join this foreign key or any other data. Then we can just browse and upload. Then it is also a serial number. So then it shows that the join options keep only matching record or keep all records. If there is no matching records are there, then if we choose this keep all record, then all the records are joined besides all the non all other record. But if we choose keep only matching record, then only matching IDs, um, primary keys IDs and foreign key IDs based informations are stored. So we just choose the keep all record or any matching record. Suppose keep only matching record. Then we just see now this attribute is joined with this previous attribute data. So it is our previous attribute data. Now this attribute is joined this serial number data because this serial number and this serial number have have the same identifications of unique identification number. There is no repeat of any number or repeat of any informations in these IDs. So all these rows have a unique ID. So these are the rows. That's why it joins. Otherwise, it shows the error. Then we can save it or export it to a new file. If we don't want this, then we can just remove and join. Remove all join, and all these information are not present. This is the technique how to use join attribute based on the primary and foreign key or based on the common unique ID. So here our serial number is the unique ID, and that's why all these data are joined. Okay.
Okay.
Then we just go to one of the example. This is a mangrove forest in Vitharkanika area, national park. So suppose I want to create a buffer line or buffer polygon outside my mangrove area, as it is a protected area and it is a national park. That's why it needs a protection. Suppose we want some 100-meter buffer line to create 100-meter buffer line. So how to create 100 meter of buffer line? So just go to geoprocessing, then buffer, then just import this mangrove area polygon, then create an output. In this output, how to where to store this output data. Suppose it is buffer 100 meters. So we have to write the buffer meter, linear unit, that is meters. So if it is kilometer, then we can change to kilometer. Then all these are correct. Then we have to OK. Then our 100-meter proximity, that is buffer line, is created. This is our buffer line based on this polygon. Suppose we have to measure this distance in meter. So it shows length is 100 meter. Okay, so it is shows the 100-meter length. So after creating this buffer area, then we just want to know, suppose this is our area and this is our village. This is our village inside this. So I want to know who is, how many village and which village are touching this buffer line. कौन सा बफर विलेज एरिया है जो इस बफर लाइन को टच कर रहा है. सो वी नीड द कंजर्वेशन एफर्ट इन दिस विलेजेस. सो वी हैव टू गो टू द selection by location, because it is a location based, not the attribute based. Then selection location, then target. So which area to be targeted? So village is targeted. Then source, which is the source, कौन सा लेयर है जिसको हम यूज करके उसको सिलेक्शन करेंगे, दैट इज बफर 100 मीटर. देन अप्लाई. Then it shows these are the villages which are selected, are connected with this buffer line, are touched with this buffer line. So these are to be needed for the conservations or for any protection activities are to be needed. So we just mark these villages, these are selected. Then we just create one attribute, just go to the table option, then add file, then just create one village for protection. Need conservation or some vulnerable village, we can change this according to our target. So we just change this village color based on this information. Category, then village protection. So previous village are looking like, then conservation village needs to be green. So this is our target. So these villages are to be prioritized for different activities, and based on this we can use our different queries. So in the village area, suppose this is the village, this is our attribute. So we have to find some information based on this village. So just go to the select by attribute. This is our query builder. We can command some functions, or we can create some information, we can get some information based on their our queries, like different logic queries are there. Suppose I want some village code equal to something number, then it select this village. Or suppose I want village protection village equal to only conservation village, then it select only these datas. Then we can also calculate area. Suppose it is in hectare. Suppose I want some villages whose area is less than 50 hectare. So how to know which villages have the area having the less than 50 hectare? So go to the area, then this symbol is a less than equal to, then click on less than equal to, then just type 50 in this area, 50, then apply. Then all the village which have less than 50 hectare are selected. This is the area of three villages, 22, 16, and 10. These are the areas. This yellow line. Suppose I want to select area of more than 100 hectare, then 73 villages are there. These are the villages which have more than 100 hectare of area. So in this area, this is our area. All are more than 100 hectare. So likewise, we can normalize this data based on this attribute. We can uh, concise our data, or we just select according to our requirement of the data the- within the lot of informations. So suppose 10,000 data are there, so we have to find some limited data based on some keywords, or based on this area, or based on this some other informations. So we can get this data based on this. So this is the query builder. These are some logics are there. Based on this, we just created. So there are some of the example and some of the practical informations are there. This is the special and non-special joining. This is already given. So in this, the IDs of different data, and this is the population data. So ID have unique data like this. So after that we can join. So we have seen this in the practical. So likewise, we will see different small part of the practical in the image interpretation section of next class, so that the theory and practical will uh, give you some basic information and clarity of the subject. Otherwise, if only theories are there, then some practical works are not uh, understood. That's why I just include some part of practical part, how the satellite data work, and how this special analysis tools are working, And next we'll go to different image interpretation keys and image rectifications, and all these are how these are done. So today we just complete this session. Okay, then
Thank you, sir. Thank you.
thank you.